We're going to start here with the file no web access 1.pcapng. And before we get going, I really want to consider what the user is doing here and what we need in order for that to be successful. In this case, we know the user is attempting to browse to a site on the internet, in this case, www.google.com. Now, to be able to do that, we have to have a couple things, right? We have to have a default gateway. We're communicating out over the network, so we need to be able to reach a router that will allow us to get network traffic outside the network. So that's one thing we need. Beyond that, we also need a DNS mapping. So we have the domain name, which is www.google.com, but we don't know what IP address that actually maps to. And we need that IP address so we can actually communicate out to that via our default gateway, via our router out to the internet. We have to have that IP address since we're communicating based upon that type of addressing across networks. So let's go through this process now and let's see if we have all of those things, and if we don't have all those things, where is the process falling down and where can we go from there? The packet capture begins with an ARP request and reply. And here I've got Mac layer resolution turned on so we can actually see the device here. And it looks like we have a Hewlett-Packard device, or at least a Hewlett-Packard network interface card in this case, sending a packet out to the broadcast address saying who has the IP address 172.16.0.10. Please tell 172.16.0.8. So that's actually the source. That's the IP address that's tied to this source MAC address in this case, and what we'll expect to see a little bit later. We get an ARP reply back. In this case, it looks like our ARP reply is actually from another Hewlett-Packard device. We see that mentioned here, Hewlett-P. The last few groupings are different, of course, because it's a unique address, but it looks like it's a response from another Hewlett-Packard device. And it says that 172.16.0.10 is at 002481, etc. It says that this particular MAC address, the same MAC address identified in the source of the packet here. So this should be our path to our default gateway. Now, I'll go ahead and tell you, this looks a little odd to me because I've not been in many networks where your default gateway, your router, is actually a Hewlett-Packard device, not in modern networks at least. So that seems a little odd to me. I might expect to see a different manufacturer there, but that's not enough to go on its own. So let's keep looking. So in this sense, we have a default gateway, or at least we think we do. And the next thing we need is that DNS domain name to IP address mapping so we can begin our HTTP TCP-based communication. Now, to do that, we're going to have a DNS request, and we see that starting here in packet 3. And we see our source IP address of 172.16.0.8. That's the client in this case. And it's sending a DNS query to 4.2.2.2, which is likely its configured DNS server. And we see that's a standard query over here for the A record for www.google.com. Now, what we would expect to see here is a response to this query, a response containing an answer that says www.google.com is at this specific IP address, and then we would take that IP address and initiate our HTTP communication. However, we don't see that. Look here, and we actually just see a bunch of other DNS queries. Now note, we have two different destination addresses here. We have 4.2.2.2, which we see here in packet 3, and we have 4.2.2.1, which we see here in packet 4. And it looks like we're alternating between these addresses. So what I think we have happening here is we're making DNS requests to a DNS server, both our primary and our secondary server. So we have 4.2.2 as our primary and 4.2.2.1 as our secondary. In this case, we don't get a response back from the first one, so the second one is tried, and this repeats over and over again, and we don't get a response back. So that's where this process breaks down. That's the last thing we see in this communication sequence. We don't see an HTTP request being made. We don't see any type of TCP session being established. In this case, we see this DNS query that is not getting a response back, and without the appropriate IP address for a specific domain name, we can't proceed on to the next step. So what's the problem here? What does this capture represent? Well, there are a couple of options. We see that here from packets 3 to 9 that our DNS request is actually leaving our system. We're actually sending those requests, so we know everything is working fine at the application layer, that those packets are being sent out to these two DNS servers. We're just not seeing a response. That means that the packet is actually leaving our system and never making it to those servers, or there's something wrong with those servers and they're not responding to those requests. Now, if you'll remember back at the beginning of the scenario, or at least in the prompt for the scenario, we said that this is isolated to a single user. It's only a single user who can't get to the internet. And our entire enterprise is using the same DNS server information. It's not like we would have a system using the wrong DNS server information. We can verify that, and I'll verify that for you here, that everyone is using the same DNS servers. And on another system, this is working completely fine. So it's unlikely that these DNS servers are both down. That's not really going to be the problem in this case. So that points us to the direction that our packets are actually never making it to the remote DNS server. They're not getting out to them. In this case, the problem actually lies here in these first couple of packets. And this is not something that would be super easy to know is an issue unless you're very familiar with the network that you're looking at. In this case, remember how we said it looked a little odd that we're getting our ARP response back from another HP device, since HP isn't really known for making enterprise routers? Well, that's actually our problem here. In this case, our system is attempting to communicate with a device that is not actually a router, not actually a default gateway on the network. So it's attempting to do that. It's attempting to communicate with this 172.16.0.10 device. And when it does that, it's sending these DNS packets out to that device. Of course, it's doing that through Ethernet addressing. So we see here our destination for this packet here. This DNS packet is this Hewlett-Packard device, this same device that's identified as 172.16.0.10. It's sending it out to that device, and that device is supposed to be forwarding that on to 4.2.2.2. But it's not doing it because it's not a router in this case. It's not forwarding that data correctly. So in this case, we simply don't get a response back. DNS in this case is based upon UDP communication. So there's no response coming back. There's no ICMP message being sent back for us to see that an issue has occurred, but that's the problem. Our default gateway is actually incorrectly configured on this system. And that could be a couple things. It could be that it's manually configured incorrectly. It could be that there's maybe some type of ARP spoofing or ARP-based attack going on, wherein this device identifying itself as an HP device is providing a response back to the ARP request. Maybe doing like an ARP cache poisoning type attack or something like that. But nonetheless, that's the issue here, is our packets are never actually getting to the DNS server, and without any DNS domain to IP mapping, we're unable to continue the communication sequence. So that's a pattern I want you to continue using. Is I want you to consider what's necessary for a successful connection, and then look at the capture and determine what's missing. Based upon that and other information, you can actually start to pinpoint the problem, or at least the probability of where the problem occurs. In this case, like many others, we're not 100% certain that this is the exact source of the problem, but it certainly points us in the right direction and really narrows down the source of the issue. We're now looking at no web access 2.pcapng, and we have a similar scenario wherein a user is attempting to browse to the internet, but they're unable to do so, or at least in this case, they're unable to access a specific site. It turns out they're unable to get to Google infrastructure or google.com, and the issue is actually only limited to that user and that particular domain. They can get to other places on the internet, but not Google, and that's what's caused them to believe that they can't access the internet in general, because that's likely their homepage. So let's take the same premise we've been working on regarding what things we need to access the internet, and let's look here and see where the issue might lie. Now in this case, we start again with ARP traffic. We obviously have to have a default gateway to get out to the internet since we're not on Google's network. In this case, we see a Hewlett-Packard device sending a message to the broadcast address saying, who has the IP address 172.16.0.102, please tell 172.16.0.8. Now, in this case, we would assume that 102 would probably be our default gateway, or at least it should be, right? That's what we want to use to send our packets out of the network. We get a response in this case. It looks like in this case it's from a Dell device based upon this MAC layer resolution that's going on. And it says 172.16.0.102 is at this MAC address identified here. So we have a MAC address now, and since we have an IP to MAC mapping, we can communicate with our default gateway and send traffic out of our network. So the next thing we need, based upon what we previously talked about, is DNS information, right? We need an IP address to domain name mapping. Since the user's inputting the domain name, we need to get the IP address associated with that. So we might expect to see that next, but look here, we don't. Going from packet 2 to packet 3, we actually go immediately to an HTTP request. And that's interesting. That's not to say we're going to have a DNS request every time. There are times, as we discussed in the DNS section, where you won't actually query a DNS server. Maybe you have something in your DNS cache already for that host, and that's not too crazy. It wouldn't surprise me if we didn't see the DNS request here. So we can go under that assumption, at least for now. However, let's look closer at this first packet being sent here, packet 3 in this HTTP transaction. We see it's from 172.16.0.8, and it's actually going to 172.16.0.102. Well, that's not Google's IP address. That's another local IP address, right? That's a little weird. We see it is it's a send packet to establish a new TCP connection. We see that here. It's going to port 80, which is the HTTP port, so it looks like a normal web request, but it's going to an internal IP address, and that's really weird. And it's actually going to the same internal IP address we saw this ARP broadcast for right here. So it turns out that this either the system maybe thinks that this 102 device, is the default gateway, similar to the scenario we just looked at, or something's happened that's caused it to do an ARP request for this device and think it is google.com. It's one of those issues. Of course, in this case, 172.16.0.102 is not google.com and does not have a service listening on port 80, which is why here in packet 4 we see a reset ACK packet. We see reset ACK here because port 80 is not opening. There's no service listening onto that, so a connection cannot be established. At that point, we see a couple more attempts for connections with the send packets and more reset ACKs, and the connection never fully establishes, and that's really our story here, is no connection can be established because the server is not actually listening on port 80. So what's our issue here? Well, we have a couple pieces of information that lead us to that answer. First of all, in our ARP request here, 172.16.0.102 is not the default gateway. We're not actually making an ARP request for that default gateway, and there's a very interesting reason why. Remember, we didn't have any DNS traffic here, so there's no request to find out what the IP address mapping of www.google.com is. That means our client system already knows that information. Well, how would it know that? One way is certainly that there might be a cache entry that already exists for that, but that actually wasn't the issue here. In this case, the system was infected with malware, and that malware put an entry into the host file of the system, which is the place the system is going to go to first to check to see if it has a DNS to IP mapping. That entry said point www.google.com to 172.16.0.102. It pointed it to an internal address, which ensured that the system would never be able to access google.com. Now, you might ask, why would it point it to an internal address? And that's something that's certainly not uncommon of malware. Maybe it had an algorithm that would look at the system's current IP address, pick a random fourth octet for that IP address, and point it to that. That's certainly something I've seen done before. But that's exactly what happened here, is malware's running on the system. It put an entry in that host file, so the system thought it already knew where google.com was, but it wasn't. So in this case, you don't actually see it doing an ARP request for the default gateway. It's doing it for this 102 address because it has to try to find that. In this case, 102 is actually address that exists. In this case, it looks like it was a Dell system based upon this MAC address. But of course, it was probably maybe a workstation, something like that, something without a service listing on port 80, so it would not respond to the request, and the request failed. So the crux of this issue is that malware was running on the system. It modified the host file, preventing the user from accessing google.com, or possibly an array of other domains yet to be discovered. So an isolated issue in this case, but one we're able to solve by, again, identifying the things we need to get out to the internet and looking for the things we don't have and what could have caused that. For our final scenario, I've opened up nowebaccess3.pcapng. So let's go through the process here. Now in this case, once again, we had a user report that they're unable to access google.com, but under further examination, we found out that no users on our network are able to access google.com. So that's a bit of a different issue than the last scenario. Now we need all the same things, and we're looking at an individual host, so let's go through that. Now, we would expect an ARP request, right? That's one thing we've talked about, is you need to be able to communicate with your default gateway to communicate out on the internet. Now, we don't see that here, but I'll tell you, it's actually okay in this case. You won't always see that. Your system has an ARP cache, and it caches those entries for some period of time. And if you're talking to a lot of other things on the internet, chances are that will be cached when you go to look at another specific request. So we don't see that here, but we know that's okay, because if we look at the first packet, we see it's a DNS request to another host out on the internet. But in this case, we see that we are actually sending that successfully, right? We see a response back, and we know if we see a response, that means we're communicating out to the internet successfully. We see we're communicating in this case to a Cisco device, which is probably our default gateway. That makes a lot more sense than some of the other things we've potentially seen earlier. And we get a response back. So we're successfully communicating to the internet, it looks like in this case. Now, the next thing we need is our DNS mapping. So we need our mapping of IP address to domain name because the user's typing in a domain name and we have to get that IP address, and we're going to do that with the DNS protocol. Starting right off the bat in packet 1, we see a standard query for www.google.com. That's what we would expect to see. In this case, we actually see a response. That's a good thing. Our DNS server 4.2.2.1 gives us a response. We can dig into this down here in the packet details window. It looks like for www.google.com, we are given a CNAME record, which points to www.l.google.com. And then we are given several A records that give us IP addresses or a range of IP addresses for www.l.google.com. So we would expect then to see a connection out to one or more of these addresses. So starting here with 74.125.95.105, that's where we should attempt to connect for browsing the google.com web server in this case. Sure enough, if we go back up here to our packet list window, we see that. We see in packet 3, 172.16.0.8 attempts a connection to 74.125.95.105, which is the IP address associated with google.com. It appears this is a TCP connection over port 80, which is our HTTP port, and it is a SYN packet, which is going to be used to establish our three-way handshake, establish our TCP session. Now, what we would expect to see is a reply back from the server with a SYN ACK, which we would then ACK, and then we could make an HTTP GET or POST request or whatever was needed there. However, we don't see that. And this is where the source of our problem lies. Instead of getting a SYN ACK back, we get nothing back. Look, packets 4 and 5 are actually the same packet. They're TCP retransmissions of that SYN packet. We're not getting anything back from the server at all. So that's clearly problematic in this case. So in this case, where does the problem lie? Well, let's go through the things we need. We need a default gateway address. We have that. We need a DNS mapping. We have that. And we need, obviously, upstream connectivity. And we seem to have that. We can connect to the internet, but we can't actually connect to google.com, and it is site-wide. Well, in this case, what we're looking at is an upstream problem. We're actually successfully getting packets out to the internet. We're actually successfully getting packets, we think at least to google.com, but it's not responding. It's not responding with a reset saying that the service is not listening like we saw in a previous example. It's just not responding at all. So this is indicative of some type of upstream problem. We don't know exactly where. It could be something in between us and Google. It could be some type of router somewhere that's down or not responding and not sending any responses back. It could be that the server is up somewhere, but it's overloaded or having some type of internal server error and not sending any type of response back. It could be any number of things, and that's an unfortunate thing with packet analysis is it often tells us kind of where the problem is. It may tell us that we're not the problem, and in this case, we're not, but it won't always give us the exact answer, and that's something you kind of have to learn to live with, and also learn when to stop digging, right? When to know when packet analysis is giving you all it can give you. So in this case, we have an upstream problem. There's something going on either between us and Google or with Google, and that's why we can't access it, and that's why nobody else on the network can access it as well. So I hope these 3 examples have been helpful to you to start to determine how you can address connectivity issues. Even if you're not a network administrator, if you're a security analyst, this is a very important skill to have because you're going to have to interact with custom malware and protocols that are attempting command and control, and maybe they're connecting or not connecting and you want them to connect, or there's a lot of scenarios here where you have to address these type of issues. So it's important to be able to understand this, and hopefully using the framework we've given you of knowing what you need to make the connection and then identifying the things you're lacking and then taking all the information holistically and making a determination about where the problem is. That's always the first step. Where is the problem? If you know where the problem is, you know whether you can do something about it. If it's on your local machine, certainly you can do something about it. If it's on your network, hopefully you can do something about it. But if it's upstream from you, chances are you might not be able to do as much about it. And these 3 exercises kind of illustrate all of those different scenarios.